Hi, everyone, and welcome to today's workshop on actionable ethics for data scientists. I'm Emily Miller, and I'm a senior data scientist at Driven Data. So to give you a bit of background on Driven Data is a data science and machine learning consultancy in the social good space. And so this means that we work with nonprofits, NGOs, governments, socially minded private sector companies to essentially help them use the tools of data science to further their impact. And we do this through a few different ways. The first is through hosting online machine learning competitions in the social good space. And this is a really great way to get some exposure to the different applications of data science for social good. And it's also a great way to build your skills by working on really meaningful data sets. And so if you're interested, I encourage you to head over to drivendata.org to see the competitions that we have currently running. We also work directly with clients, and we get to work across a wide variety of subject matter areas, ranging from financial inclusion to disaster risk management to wildlife conservation, and many, many others. And then apart from our competitions and our direct client work, we also devote some time to building open source tools that is really our way of additionally giving back to the data community. And so today I'm going to talk through one such tool, which is focused on data ethics. So to give you a lay of the land of where we're going today, we're going to start just with a quick overview of what data ethics is and why it matters. And then we'll spend a lot of our time talking about an actionable approach to integrating data ethics into our work. And so for this, we're going to talk about Dion. This is a tool that we built that lets you easily add an ethics checklist to your data science projects. And so for this, I'm going to give you a bit of a background on why we built the checklist, right? Some of our perspectives in building the tool. But we're really going to spend the bulk of our time today walking through the checklist content itself. So the checklist content is not designed to give you simple answers. It's not going to tell you to remove variable X or variable Y from your model. But it's really designed to help you surface the different ethical considerations that come up throughout the course of the data science process. So I've seen a lot of conversations about data ethics that often just reinforce that data ethics is important, but they don't really tell us what to do about it. And so our goal with Dion was really to give data scientists a practical way of starting to ask these questions and figuring out how they can really integrate these ethical considerations into what might otherwise just seem like technical decisions. I'm also a strong believer in the power of example, and so I'm going to be giving you concrete examples of times where things have gone wrong to really help make some of the concepts in the checklist feel more concrete and a bit more clear. And then lastly, we're going to reserve some time at the end for a case study discussion. And what we're going to be doing there is starting to apply some of the questions that we've been talking about to an actual scenario, right? To say, what are the ethical questions here? What are some of the ways that we might navigate some of the trade-offs and the nuances in this work? And this is all going to be over chat. And then lastly, I invite you to write your questions in the chat at any time. This talk is a recording, and so when you're watching this, I will actually be live in the chat and able to answer those questions in real time. So let's dig in. So we'll start with ethics, just a straight definition. So we're not going to go too far into philosophy today. We're just going to take the dictionary definition that defines ethics as the moral principles that govern a person's behavior or the conducting of an activity. And so when we think about ethics, we need to remember that ethics is hard, right? There are trade-offs that are just inevitable. As economists like to say, there is no free lunch. It's important to remember that there's not one right answer here, right? And that we can expect reasonable people to disagree on the course of action. And if you take away just one thing from this talk, I hope that it is this, and that is that good intentions are not enough. We have to intentionally consider the consequences of our actions, and just not intending harm is not enough to ensure that we don't actually do harm. So I'm not going to tell you, right, what to do or what you should do or what the answer is, but I am going to give you a practical starting point for incorporating ethics into your data science work. So why does data ethics matter? Well, we all know that data is important, and we've seen, right, a number of articles telling us that data is more important than oil, and data scientist is the sexiest job at the 21st century. And in short, what we see is that data is impacting industries across the board, from healthcare to the criminal justice system. And so what this means is that as the use of data becomes more widespread, so do the impacts of the way that that data is handled and the way that algorithms are designed. And so we've seen a number of cases where this has already gone awry, and we see, right, well-intentioned models perpetuating systemic biases and perpetuating inequalities. And so I think we can all agree that integrating ethics into data science and machine learning and AI is increasingly important, right? But many conversations about data ethics are relatively theoretical, and it makes it hard for practitioners to really integrate this into their daily work. And so our goal was or at least our starting point was really to say, what is an actionable and a practical way to get data scientists working on data ethics? And so for this, we built Dion. Dion is an open source command line tool that lets you easily add an ethics checklist to your data science projects. So let's break down exactly what that means. So first, it's a checklist. Why did we make this a checklist? I want to call out that we were heavily inspired by previous work, in particular of oaths and checklists written by Mike Lukides, Hilary Mason, and DJ Patil. They've done a lot of great thinking on why checklists are important. And to summarize some parts of that, the first is that checklists help connect principles to practice. Essentially, they help us translate these big picture ideas into everyday tasks. Checklists are also much more specific than oaths. So oaths, for example, can be quite vague, such as do no harm, whereas checklists are designed to be actionable. They are specific, they are focused on execution, and they are designed to be used repeatedly. Lastly, checklists help ensure that we don't overlook important work, right? They help us integrate these conversations into our workflows to make sure that these important conversations are happening even in relatively fast-paced environments. So by now you might be thinking, okay, a checklist, that sounds great, but why did you make this a Python package? Why did you not just write this as a Google document and leave it at that? And the reason for making this a Python package is that we really wanted to keep data scientists in their normal workflows. We wanted to keep them at the command line, working in Jupyter notebooks, working in text editors. And so that was one of the reasons why we made this a command line tool. There are added benefits here as well of Dion is scriptable, meaning it's easy to put it in a bash RC or a make file and have this be a command that's run at the beginning of each project. It's also customizable, and so we make it really easy to pass in custom checklists that can help capture some of these domain-specific needs. So taken together, this makes it really easy to just at the start of a project, generate the checklist, open a PR, right? Use that to start this discussion among your team, and then the checklist can be in GitHub and tracked, and as people are having these discussions, right, you can document the decisions that are being made. And if you're just doing a one-off analysis, so say you're just working in a Jupyter notebook, you can also output the checklist to the Jupyter notebook directly and engage with some of the questions right alongside the analysis that you're doing. So Dion takes only 2 lines of code to use. The first is to install it, pip install Dion, and then the second is to output the checklist to the file of your choosing. And that's all it takes to get started. So before getting into the content itself, I just wanted to share a few perspectives in building the tool. So the first is that our goal is not to be arbiters of what ethical concerns merit inclusion, right? The checklist is designed as a reasonable default, right? A helpful starting point that captures a broad set of concerns that come up during the data science process. But we strongly encourage teams to design and customize checklists that capture some of the domain-specific concerns that they might be facing. Secondly, checklist items are meant to provoke discussion. So you'll see this when we go through that the checklist items are not telling you to remove a specific variable, but they're framed as have we tested and have we considered, right? They're not designed to recommend this specific action, but rather to prompt the necessary discussion so that we can be intentional about the choices that we're making. I also want to call out that decisions on the ethical course of action are not up to data scientists alone. So we designed this checklist to provoke conversations around issues where data scientists have a particular responsibility. But this, of course, should be happening among a broader organizational commitment to doing what is right, right? This is not on the shoulders of data scientists alone. And lastly, statistical best practices are not included in the checklist. The checklist is really meant to go above and beyond statistical correctness. So the checklist is broken up into 5 sections: data collection, data storage, analysis, modeling, and deployment. And this is because there are different ethical considerations that arise at different parts of the data science process. One of the things that we did when we put together the documentation for Dion was to compile examples of times where things have gone wrong. And we have at least one example for every item on the checklist. And I'm going to share a few of these today as we go through the checklist content, but you can find all the links to the examples that I give and more at dion.drivendata.org/examples. So one of the reasons why we have these examples is really just to help make some of the items on the checklist be more concrete and to help illustrate where in the process having some of these discussions might have helped provide a course correction. So now I'm going to walk through the checklist content itself and give you a sense of what's on it, as well as just one example in each section just for time. So we'll start with data collection. Our first item here is informed consent. So if there are human subjects, have they given informed consent? And by that, we mean have subjects affirmatively opted in, and do they have a clear understanding of the data uses to which they consent? So this is really important to avoid having exploitative relationships and making sure that people have an understanding and control over what data uses they are consenting to. Secondly, we have collection bias. This asks, have we considered the sources of bias that could be introduced during data collection and survey design and taken steps to mitigate those? So there's a lot written about how we think about designing representative samples in the statistical literature. And this is, of course, really important, but this also goes beyond that, right? It's thinking not just who do we have in our data set, but who were we unable to capture, right? And are there sources of bias that we have inadvertently introduced in the way that we have conducted the survey, right? So if we've asked people for their gender and we've given them 2 responses, male and female, then we've now excluded the portion of the population that identifies as non-binary. We also want to think about limiting PII exposure. And so by this, we mean, have we considered ways to minimize the exposure of personally identifiable information, for example, through anonymizing the data or by not collecting information that isn't relevant for analysis? So if we don't need people's phone numbers for the analysis, then we shouldn't be collecting them, right? Having PII around that we do not need is both irresponsible and it just exposes us to potential data leaks. Lastly, we want to think about downstream bias mitigation. So have we considered ways to enable testing downstream results for biased outcomes? So when we start talking in the analysis section about fairness across groups and understanding, is our model unfairly discriminatory in certain ways, having data on some of this protected group status like race or gender can be really helpful, even if we don't want to use that in the model. So the idea here is to think upfront in the data collection section, are there pieces of data that we need in order to check for fairness, say, between men and women, even if we don't plan on using gender in the model? And you'll notice that there's a tension here between limiting PII exposure and downstream bias mitigation, where there's certain data that increases your PII exposure, but also improves your ability to monitor for bias in your results. And so this is just to say that, right, there's not a straightforward single one-size-fits-all piece here. These are the tensions that we need to have conversations about so that we can figure out what the right trade-off is for the work at hand. So where have things gone wrong in data collection? I want to return to collection bias and talk about passively collected data because it can be a bit harder to spot collection bias in passively collected data, but all the just as important. So there's an app called Street Bump, and the idea is to passively detect potholes using accelerometer and GPS data. And then these potholes would be reported to the city government, who can then use this information to make, data-driven decisions about resource allocation. And so this on the surface sounds great. We're not bothering people. We're figuring out where the potholes are so we can allocate resources more effectively. But we run into bias here because we need to think through who has smartphones, right? We know that elderly people are oftentimes less likely to own smartphones, and this can also be the case for certain lower income groups as well. And so because of that bias, we can end up having over-reporting of potholes in younger and richer areas, and then this results in these unfair discriminatory effects based on the bias in how we've collected our data. So moving on to data storage, it will come as a surprise to no one that data security is really important. And so here we're thinking about, do we have a plan to protect and secure the data? And so this can mean a whole host of ways of doing this. Just to throw a few examples out there, things like encryption at rest and in transit, having access controls on internal users and third parties, having access logs and up-to-date software are just a few things that we can think about in how we want to protect and secure our data. We also want to think about the right to be forgotten. So by this, we mean, do we have a mechanism through which an individual can request their personal information be removed? So this is particularly important in light of GDPR, which actually explicitly includes the right to be forgotten, which is also known as data erasure, and allows an individual to have their data both be removed and to halt any third-party processing of their data. And then lastly, we want to think about our data retention plan. So is there a schedule or a plan to delete the data after it's no longer needed? We don't want to just hold on to data forever, data that's not being used. This just exposes us again to avoidable data security, data leaks, or potential privacy breaches. So where have things gone wrong? Well, for this, I want to turn to Equifax. And for those who aren't familiar with Equifax, Equifax is a credit reporting agency. And so what this means is that when you request a loan, say to buy a house or a car, the lender will go to Equifax and get information on your creditworthiness to basically figure out if you should get a loan and what the interest rate should be. And so because Equifax is in the business of assessing creditworthiness, they have a ton of personally identifiable information. They've got salary data and tax data and social security numbers and driver's licenses, addresses, a whole host of things. And so what happened back in 2017 is that hackers exploited a website vulnerability and they stole the personal and the financial data for more than 146 million people, which was a breach on a record scale. And one of the particularly interesting things here is that once the hackers got through the kind of first vulnerability, right, that first layer, they basically gained the keys to the kingdom because despite having this trove of PII, Equifax did not have multiple layers of control. So now we're on to the analysis bucket. This is probably my favorite section because there's just a lot of really good things in here. And so we're going to start with missing perspectives. And missing perspectives asks us, have we sought to address blind spots in the analysis through engagement with relevant stakeholders? For example, checking assumptions and discussing implications with affected communities and subject matter experts. So this is really important, especially for us at Driven Data, because we work across a wide variety of subject matter areas, right? Energy, health, and financial inclusion. And we're not experts in all of those areas. And so a really important part of our process is working with the client, working with stakeholders, checking our assumptions, seeing if we've defined definitions in a correct way, and having these conversations that help us to ensure that the work that we're doing has the impact that we intended to have. We also need to think about dataset bias. So here, this is, have we examined the data for possible sources of bias and taken steps to mitigate or address those biases? So no matter the work that we've done on data collection, which is, of course, very important, our data set will still be biased. So the question to ask here is not, is my data set biased, but how is my data set biased? So things that we want to think about here are stereotype perpetuation, confirmation bias, imbalanced classes, omitted confounding variables. All of these things can result in biased modeling results. And so we want to take a good chunk of time up front to think through what are these sources of bias, and then what are the different ways that we can start to mitigate these in our analysis. So to give you an example on dataset bias, there's a widely used commercial algorithm in the healthcare industry. And the goal was to identify patients with complex medical needs so that they could be referred to programs that gave them extra care. And a study found that this algorithm was consistently underestimating the care needs of Black patients and assigning them lower risk scores compared to equivalently sick white patients. So why did this happen? Well, the model was using health costs as a proxy for health needs. But health costs they have racial bias encoded in them. And what I mean by that is that there is less, so essentially health spending is lower on Black patients than on white patients. And that's not because Black patients are not as sick, but because there is unequal access to healthcare. And so when using this biased proxy, right, our model is learning from the data, but when our data has this racial bias encoded in it, then the result of the model is to underestimate these care needs and essentially deprive Black patients of care. So there's three other checklist items on analysis. And the first is honest representation. And so I love a good data visualization. I think that they are a lot more exciting than tables, and they can be a really powerful communication tool. But for those who build data visualizations, they have great power as well as great responsibility. And so here we need to think through, are our visualizations, our summary statistics, and the reports that we design honestly representing the underlying data? So have we used a dual axis chart when a single axis would have sufficed? Have we used color in an intuitive way to help people get the correct conclusion from the visualizations that we've created? We also want to think about privacy in analysis. So have we ensured that data with PII are not used or displayed unless necessary for the analysis? So we want to make sure, especially if we're working with sensitive information, that we're not inadvertently revealing any PII in the visualizations that we're creating. And then lastly, auditability. So is the process of generating the analysis well documented and reproducible if we discover issues in the future? So by auditability, essentially what we think about, so take Jupyter Notebooks, for example. We want to be able to restart and run the notebook and get the same results. We want our analysis to be clear and well documented, not only because that helps us prevent errors in the first place, but it means that if there's an error that's discovered later, it makes it much more straightforward to go back and fix it. So let's talk about modeling now. So modeling starts off with proxy discrimination. Have we ensured that the model does not rely on variables or proxies for variables that are unfairly discriminatory? So here you can think, for example, about protected classes like gender and race. And so it is one thing to not include those variables in a model, but if we have variables that are highly correlated with gender or race, then you're going to end up picking up those effects that you're trying to exclude. And so you want to think through not just what are the variables that I have in my model, but what are they correlated with as well. Fairness across groups is really important here. We want to be testing our model results for fairness with respect to different affected groups. One way of doing this, there are many, but one is to look for disparate error rates, right? Thinking about what are those subgroups to make sure that we're not doing way better on one group than another group, right? This is a source of bias. And there's a number of cases out there where models do much better on one group than another, and that this fairness hasn't really been reconciled. And then in our metric, we want to think carefully about the metric that we're using and think through what are the effects of optimizing for our defined metrics, and have we considered additional metrics? So this can feel like a technical choice, right? Are we looking for accuracy or F1 scores? But this question helps us to think through what are the impacts of choosing that metric, right? What are we actually optimizing for? What are we not caring about? What is not captured in our metric, right? And are there other desirable outcomes that we do care about where it might make sense to bring in additional metrics, right, to capture that? Another piece here is thinking about, right, what is a false positive and what do a false negative look like? And do we have the right trade-offs here given what that looks like in real life? We also want to think about explainability. So can we explain in understandable terms a decision the model has made in cases where justification is needed? So explainability has become especially important in healthcare, and for good reason, where there are certain sets of models that are much more explainable than others and become really important because we need to understand why certain models are making the decisions that they are, and it becomes not just about that predictive power. And finally, communicate bias. So have we communicated the shortcomings, the limitations, and the biases of the model to relevant stakeholders in ways that can be generally understood? So what I mean by this is that it's easy on the data science team to have an understanding of the shouldas and the wouldas and the couldas, and if we had more time, we would have done X, and the model does well here, but does less well there, and understanding those limitations. But it's important that we communicate those to the client or to the downstream user of the work so that the analysis can be understood in the context of its limitations, right? So that those limitations don't stay just as knowledge on the data science team alone. So where have things gone wrong here? I want to return to proxy discrimination and talk about a recruiting tool. So Amazon tried to build a recruiting tool. You can envision it as, you pass it 100 resumes and it tells you the top 5 people to talk to. And they ended up scrapping it because it showed bias against women. And the interesting thing here is that Amazon had actually taken quite a bit of care in thinking about this and had excluded names from the model and had excluded gender from the model and was examining the model for how it performed right on men and women. And what they found is that the model, even though gender wasn't in the model, had picked up other ways of identifying women. So either specific language that they used, or being captain of a women's chess team, or going to an all-women's school, or other ways that the model had picked up on this. And so this reinforces, right, how important it is to think about what is our model picking up on, and what are ways that we might be discriminating, even if we don't have that explicit variable used in our model. And lastly, deployment. So we start off here with redress, thinking about, have we discussed with our organization a plan for response if users are harmed by the results? So we want to think through, right, how do we evaluate these cases, and what is our process for updating models if we find that there's harm that's being caused? We also want to think about rollback. So is there a way to turn off or roll back the model in production if necessary? So if we discover that our model is causing harm, right, what is our process? Do we have a way that we can, right, turn off the model or move it to an earlier model to avoid that harm? Thirdly, concept drift. So do we test and monitor for concept drift to ensure that the model remains fair over time? So concept drift can be a bit tricky to understand, but essentially what we mean here is, did the statistical properties of the target variable change over time? And in simpler language, this is basically a measure of, did our world change? And if so, is our model still valid? And I'm going to give an example of this in just a moment to make it a little bit more clear. And then lastly, unintended use. Have we taken steps to identify and prevent unintended uses and abuse of the model? And do we have a plan to monitor these once the model is deployed? So we obviously can't see into the future and foresee all the ways that models might be used and abused, but we do want to spend some time thinking about, are there ways that we can help mitigate this? So there was an example of a very powerful text generation model that researchers had created, and they deemed that the risk was too high to release it in its full form. And so they released, I think it was a partial data set, and didn't release the model in its entirety out of essentially public good. So to return to concept drift, I want to talk about predictive policing. And so in predictive policing, the way that this works is that past crime data is used to determine where police officers should go next. But what ends up happening is we get this feedback loop, because police officers are sent to an area and they find crime, and then the model says, okay, there was crime there, send police officers where that crime is. But we've lost the comparison that says, is there more crime where the police officers went compared to where they didn't go? And so now we have model decisions that are impacting the future data that is fed into the model. And that's where we get this feedback loop that repeatedly sends police officers back to the same neighborhoods, regardless of the true crime rate. So that is the overview of the checklist in all 5 sections. I do want to call out that your project might not capture all 5 pieces of the data science process, and that is entirely okay to have, data collection not be relevant because you weren't involved in data collection in the work that you're doing. And so as you're working through the checklist out in the world, pick the sections that are relevant to the project that you're working on. So in the last piece of this, I want to start translating this checklist into an actual scenario. So it's one thing to listen to the checklist and say, yeah, that generally makes sense. It's another thing to start asking those questions and thinking through, right, what would I do in this scenario and what metric would I choose? And one of the things that I find in my work is that as I use this checklist, going through it becomes easier. As you start to do it routinely, you get more adept at seeing the ethical considerations in your data science work. And so this last section is really just to start building that muscle. So I'm going to give us a mock scenario, and then in the chat, we're going to start having a discussion. But before we move over to the chat, what I want everybody to do is to first pull up the checklist. And so the easiest way to do this right now is to go to dion.drivendata.org/default-checklist. I will drop this link in the chat as well. And so please pull up a new tab, open up the checklist, and it should look like this. It tells you you're in the right place. So I'll give everybody a moment to do that. Great. So our scenario today is that a bank wants to lower the default rates on their loans. And so they hire you, a data scientist, to help them improve their creditworthiness assessments. So your task is to build a model to predict whether a loan should or should not be approved. And the data set that you have includes all the fields contained on loan applications. And so this includes the applicant's name, their sex, their education level, their marital status, their income, their occupation, their credit score, their savings account balance if they have an account, their desired loan amount, and their loan purpose. And so what I want you to do is pick one section of the checklist. So this can be modeling, this can be data collection, and I want you to start working through the questions in that section as applied to this scenario. So you might think about data set bias, for example, and start thinking about who's in this data set, who's not in this data set, right? And why does that matter? What impact is that going to have in our modeling? Or you might take metric selection and think through what is the metric that we would want to use here, and what actually, in optimizing for that metric, what are we prioritizing and what are we missing in that metric as well? So we're going to move this entire discussion over to the chat, and I'm going to be moderating there. And so for now, what I want you to do is to share which ethics checklist question that you're thinking about and share some of your thoughts of what are some of the ethical considerations that you see as being particularly relevant here. Thanks everyone for the great discussion in the chat. I want to leave you with this quote today by Richard Feynman, who says that the first principle is that you must not fool yourself, and you are the easiest person to fool. So you have to be very careful with that. So my hope is that today, even though I have not told you what the right answer is or what you should do, but hopefully this framework has given you a way to try not to fool yourself, right? Hopefully it has given you a set of questions that you can ask so that you can be intentional in your choices and so that you can move beyond just having good intentions. Thank you all so much for coming. You can learn more at dion.drivendata.org. I hope that you find Dion to be a useful tool, that you share it with your teams, and thank you again for coming.